Hi, folks. Kent Hovind here from Dinosaur Adventure World. It seems like you folks are waiting for Non-Sequitur to start. Maybe if you wait long enough, it will actually evolve into a good show. I'm sorry, folks. Looks like I need some water. Anyway, the Lord told me I needed to warn you folks that this podcast is full of crude humor, facts, and critical thinking. So if those things offend you, like they do me, now is the time to close out this window. But if you think elephants and pine trees are related, then hit that subscribe button and click the bell so that you know every time this blasphemous channel goes live. Okay, I need to get out of here. You never know when Aaron is going to make an appearance. Hovind out.
Non-sequitur. Your facts are uncoordinated. Non-sequitur. Your facts are uncoordinated.
Well, we waited long enough and our show evolved, not so much into a good show, but at least to where we can actually have a show tonight. So I appreciate everybody's having a little tolerance and patience tonight. A lot of things happened today, which we had to push back. Kyle is still out of town. Not sure when he'll be back, but he's enjoying some time away. And we have a producer back though. We have actually Dave with his actual setup. Welcome back, Dave. We've missed you. So we had to take a little time to get this set up. So tonight, though, we have Aaron with us. If you remember back, it wasn't that long ago. Aaron was here talking about astrotheology, and he has his own channel, Rufus Cat 2, and he's back to talk about electric universe theory because we kind of touched on it a little bit during those discussions. But I was hoping we could kind of find somebody who could kind of at least address the topic better than I can, because I've been out of this for a very long time. Electrical engineering is not my area of knowledge by any stretch of imagination. So I've reached out to a few people. I haven't got a response from any of them yet. I do know one plasma physicist, but he lives in Italy, so it's 2 a.m. there. So if you guys are in the live chat familiar with this topic, please, by all means, help me out here, because I'm going back a lot of years to remember my electric universe theory, I guess you can say. So anyways, Aaron, welcome back. Aaron, you were there. Please evolve and be with us. We wait long enough, it'll work. There we go.
Can you hear me now?
Yes, I can hear you now.
Hear me now. All right, cool. Good to be back. I get Steve all to myself, and I'm gonna dub Dave actually Dave, because what you just said a second ago, it's actually Dave. So from now on, Dave shall be known as actually Dave.
I call him more virtual Dave.
And you know, Steve, there was something I wanted to throw at you just for fun. Are you familiar with the Steve Project?
Of course. Yeah, the Steve Project was set up to kind of parody the Discovery Institute's thing where they put out there trying to tell people that evolution was somehow not believed by a lot of scientists, and a bunch of scientists supposedly signed that evolution.
There had seven. They had
controversy.
I think they said the Discovery Institute said they had 700 scientists who did not believe in evolution, and then the Steve Project came out and said that they had 1,300 scientists named Steve or variations of the word Steve, like Stefan and Stephanie and Stephen. So they had like 1,300 scientists just named Steve who did. So they it was hilarious.
Well, the whole methodological approach of the Discovery Institute is questionable to begin with, but what they did was basically they phrased something in a way where most people that don't understand the topic would probably have signed it as well. I kind of we would have signed it, depending on the way they phrased it was very disingenuous, but most people that signed it, they didn't understand what they were signing, and they weren't scientists to begin with, or they especially weren't scientists in biology. So there was a huge,
they weren't scientists in what they would call life scientists. That's correct.
I don't know if I would sign it or not. I would say this, that I read their actual statement that they had for that, and I wasn't that questionable. I mean, there was, of course, the way they phrased it, but if you read into it, it's basically saying that, you know, students should be taught various types of different approaches to things, and even in scientific theory, there's different potential ways of looking at things, right? But they're not saying, no scientist in his right mind, and no biologist would ever say we need to teach creationism, next evolution, or in this case intelligent design, which is it's just a fancy form of creationism. And it was very dishonest, and they got called out for it, and the Project Steve made a mockery of all that, as well as the
Yeah,
school.
yeah. Yeah, it was brilliant. In fact, I learned about that because I'm reading Aaron Ra's book, The Foundational Falsehoods of Creationism, which is extremely well-written book. That's where I learned about Project Steve.
Yeah,
I met
I've read
Aaron
most of it. Yeah.
I met Aaron Ra recently at the Ark Encounter protest of 2018. I drove up to Kentucky to participate, and I met Seth Andrews and Aaron Ra, and I got a signed copy of Aaron's book. And I've read, I do a fair amount of reading, and Aaron is a really, really good author. His writing is very, very readable, very easily understood, and very profound and very well researched. So kudos to Aaron.
Yeah, I
I'm
love
about
his
100.
foundational series. What's that?
I'm about 100 pages into his 450-page book of foundational falsehoods, and I know you mentioned that you had read Velikovsky, Worlds in Collision. When you were a teenager, I think you said.
Yeah, high school.
I actually have a copy right now. I just got my hands on 3 Velikovsky books a couple of weeks ago, and I just started about 35 pages into World in Collision right now. I just started reading World in Collision, and I'm sitting here looking at 2 other copies. I've got Earth in Upheaval and Mankind in Amnesia, and I can't wait to get into those books. It's really good stuff.
Yeah, well, Velikovsky was a legit scientist. He was just working with the information he had at his time. I mean, I'm sure you're familiar with the Velikovsky incident, but you know, he
probably not as much as you.
No, not really. I mean, I haven't looked into stuff in a very long time. You know, basically, he was charged, you know, of being a pseudoscience and things of that nature. And you know, nowadays, yes, I do think it's pseudoscience, but I think at the time he was actually trying to do what he would consider to be academic work, and at least based upon some of the knowledge we had at the time. I mean, we're going back way back when we didn't even understand things about magnetic fields of the planets, right? Mercury, we didn't have a probe. Venus didn't have probes. So we really didn't understand the dynamics between the electromagnetic field and the atmosphere. I mean, I'm sure you're going to talk about Birkeland currents and how that relates to the magnetosphere and the ionosphere and all that. You know, we didn't know any about any of that stuff. So we understand a lot more than we do than Velikovsky did back then. But anyways, what are you bringing for us tonight?
Well, I sent a file that had, I think, maybe 95 images that are basically screenshots from presentations from the Electric Universe, from the Thunderbolts Project website, from Thunderbolts Project YouTube, and so I would like to go through at least most of that presentation as much as possible. I'll move a little quicker than I did last time. I don't want to gobble up 2 hours of just talking about my pictures. I would like to have a little bit of a discussion with you and some back and forth. I know that you're a little more versed in physics and physics terminology than I am. Now, I'm certainly not a physicist. I don't claim to be. I don't have a doctorate. I'm not a physicist. I'm not a scientist. But I'm no stranger to these subjects. I mean, I took electronics in high school. I thought I was going to get into electronic engineering. I took several years of electronics in high school, and I did very well in math. I was doing trigonometry before I left high school. And so I did well in science. I did well in math. And these subjects fascinate me endlessly. Another aspect which ties into our previous discussion about astrotheology is that when I was a young man in school, one of my English teachers exposed me in the class to Homer's Iliad and the Odyssey. And so the Greek mythology really stuck with me. I was endlessly and still am endlessly fascinated with Greek mythology. And this whole range of topics, from mythology to science to modern times, it all ties together, and the thunderbolts and the electric universe ideology or thesis, um, being a new idea, relatively new compared to mythology, at least, um, it, it, it certainly lends to the idea of astrotheology when it comes to, like, our last discussion when I talked about astrotheology being that the gods were planets, and there's no secret about that. All of the ancient gods were well known to be the planets, and it seems that in our ancient history and our ancient mythology that there is stories of the gods having wars in the sky, wars with each other, wrath upon mankind, lobbing thunderbolts at each other. Zeus and Thor are well known to be wielding thunderbolts, and there is mythology that goes well beyond our history, all the way back to petroglyphs that have been found and carved in stone, written in caves, painted on cave walls. And so there seems to be a congruency of these ideas, and that is what David Talbot has put forward in regard to the Electric Universe and the Thunderbolts project. Now, earlier when you and I spoke, you said you wanted to get some physicists on to talk about the Electric Universe. So I wanted to ask you just quickly, have you even bothered to reach out to, like, Wallace Thornhill or Walter Scott, or I don't know if he's still alive, but maybe Halton Arp?
No, I mean, Arp is, pretty sure is dead, actually.
I think he
But
probably
no,
is. I don't know.
I'm pretty sure that he's dead, but I would have to look to see if he's still alive. But no, the people I reached out to, people that I know, and they're one's a plasma physicist in Italy, and then I have an electrical engineer friend that is very, very well versed in electrical theory. His name's George, but I wasn't able to get a hold of him either.
Okay, so I would highly recommend at least trying your best to get your hands on Wal Thornhill for an interview, because there is nobody on earth better to represent the electric universe than Wal Thornhill. And I only hope, and I genuinely hope that I can at least do the electric universe some honor this evening. And like I said, most of my in fact, all of my presentation, no, not all, 99% of my presentation will be basically taken straight from their own symposiums, presentations, and conferences, and talks, and lectures, and their own documentaries.
Yeah, I know who Thornhill is, and Talbot. They were active on Reddit for quite some time.
Oh, were they? Well, I
Yeah,
can
or at
tell
least
you
their
that
advocates or that there's this whole subreddit on Electric Universe, and Thornhill, I guess, was a big fan of Talbot, if I remember correctly.
David Talbot.
David Talbot, yeah.
So David Talbot is really more geared towards the mythological aspect of the Velikovsky thesis. Okay, so David Talbot basically picked up the ball where Velikovsky left off, and with modern day with internet, was able to do a lot more research and deeper research. And I'm going to show you a lot of screenshots that David Talbot has basically dug up and put together from around the world, from, like I said before, cave drawings and petroglyphs. And David Talbot is the guy on the mythological end of this idea, which really is a little bit more near and dear to my own heart. But I did well in science, and I did well in math in school, and I thought for a while that I was going to be an electrical engineer, and I took years of I took several years of schooling in electrical engineering. So I'm not unfamiliar. I'm not a total stranger to the science aspect. But again, I will remind you that I'm not a physicist, and I'm probably not the best guy. I mean, if you want to seriously challenge me on the physics side of some of these ideas, you would do well to roast me like a flat earther. Okay, so
Well,
I
we'll
hope
start with
that
you, and
doesn't.
then we'll try to get maybe one of the other guys. By the way, Halton Arp did die in 2013, so he died about 5
13.
years ago.
Okay,
I thought that he had passed.
okay,
So because he was an old dude, but
okay. I'm not
anyways,
surprised. Uh,
yeah,
you
I'm not
do
surprised
know
either.
who Halton Arp was, though, right? I mean,
Oh yeah, of course, yes, yeah, he
okay.
was an
So
astronomer.
Halton Arp, for those listening, not only astronomer, Halton. Excuse me. Yeah, Halton Arp was Edwin Hubble's assistant for many, many years, and Edwin Hubble and Halton Arp both actually later. Although, let me back up one step. While Hubble is credited for the redshift, which we now identify in mainstream physics as being a measure of velocity. Okay, so if it's red shifted, then it's moving away from you. If you observe something and it's blue shifted, then it's generally accepted as moving toward you. Okay, so I know that you understand the redshift principle,
Sure.
and that, so Hubble is accredited for that. And for those people who are at least as old as I am, who enjoyed the Cosmos series by Carl Sagan, Edwin Hubble was lauded as being the guy who was credited with that. Although it wasn't his theory, the Big Bang theory was actually, I think it was a priest, was an astronomer priest who was actually credited by putting together. Okay, great, thank you. So yeah, so you understand that Halton Arp was Hubble's assistant. I'm not sure if you're aware, but Halton Arp and Hubble both actually questioned whether or not the redshift actually depicted the reality of velocity. Okay, so they even questioned their own theory. Okay, and it's in their own writings and in their own quotations that they themselves questioned that whether or not the redshift actually showed velocity toward or away from the observer. So that's
yes,
that.
but first of all, there's a couple things that you said are a little off, but Arp's he believed what's called redshift quantization. He used to study quasars, quasi-stellar objects, and these redshift quantization things was just a hypothesis out there to try to explain why you have a certain amount of shifts in galaxies and quasars in some kind of quantized value. You would look at the data and it would look like they were in specific areas where you'd have this most amount of quantization of redshift. Creationists have actually taken that and they ran with it, but then they found out that they did much more observations of these quasar-stellar objects that quantization seemed to just go away. So it's just a small sample size was the issue. But anyways, I think that's kind of a sidetrack there. But yeah, I'm familiar with the topic.
Okay, so I'm looking at the side chat, the internal chat. It says, "Hi, Aaron, just sent you an email. Reply, please, and attach the file." Was that you, Dave, that typed that? Who typed
Yeah,
that?
that's me. That's me. I decided to use my phone microphone so I'd sound a little bit clearer. But I think your discussionals were on the subject or on when Kyle was producing. I was actually taking some time off myself, so I don't actually have your slideshow at all.
Okay, I sent my slideshow in both in two different Google Drive files that Kyle sent me. First, for tonight, Kyle sent me a Google Drive, and I tried sending my files, and it kept telling me that I didn't have permission to upload. And then when I clicked the new button, it said I didn't have permission to alter the file. And while that was being corrected, I took the initiative and I went back to the old original Google Drive that Kyle sent me last week when I did Astrotheology. And that particular drive allowed me to upload my files. And then Kyle texted me and said, okay, now you can alter the file. So then I re-uploaded to the new file that Kyle sent me. And that also worked. So you should have 2 copies of my slideshow.
Well, I don't actually have the Google Drives he sent you, so
Okay, well, I'll
This has
tell you
been
what. I got my. I will
yeah.
check.
Can you send me?
I'm checking my email now. David F. That's you.
Yep, that's
Um,
me.
you say
And
you
you can
don't
send
have
my
a file.
Yeah.
All right. Do me a favor, Dave. Send me a Google Drive because I've got a folder that's got about 90 plus images that I want to run through as quick as I can. Can you send me a email with the Google Drive so I can drop this folder in it?
Yeah, I'll go ahead and create a shareable and give you permissions. So give me a second.
Sure, no
Oh, by the
problem.
way, I'm not exactly sure how to pronounce Dimitri's name. There's a couple different ways I've heard it pronounced because he was a Belgian priest. So if you actually know how his name's actually pronounced, I always thought it was Dimitri, but I'm not quite positive on that. I've heard different things.
Well, you know, I myself have had trouble. I sometimes conflate the two personalities, Halton Arp and Hans Alfvén. And Alfvén is Alfven, and I've heard it pronounced Alfvén or Alvane. And so I have trouble remembering those two names
Yeah,
sometimes.
foreign names are tough. I was reading Freed lately and Frege or Frege, you know, and it's like, how do you pronounce that? Or Goiter or there's a whole bunch of these names, and it's just like I don't know how to pronounce half these foreign names. Girder, yeah, Ludwig Girder.
Okay.
I think that's how you pronounce it in the German.
So while we're waiting for Dave, I just want to run by you a little bit of the story of the mythology or the mythological aspect of Velikovsky. And probably everybody is familiar with Clash of the Titans, right? Because there was a recent remake, and most of the older generation are familiar with the original Clash of the Titans. And the concept and the story of Clash of the Titans comes from the idea from the ancient Greek mythology that Kronos, which we all know is Saturn, that Kronos was overthrown by his children and thrown into Tartarus. And then the new children, which is Zeus, which is also a solar deity, have now, taken command or ruling the world or whatever. So this concept of in the mythology that Kronos was overthrown. So in Velikovsky's thesis that Earth was once part of a planetary system with Saturn as the brown dwarf star. So Earth, Venus was ejected as a comet, according to Velikovsky. Earth, Venus, and Mars were actually part of a system with Saturn as the center, Saturn as the star. So considering this idea of the mythology, that Kronos was overthrown by the sun, Kronos' children, Kronos' sons overthrew him. So now we live in a world where the sun is the center of our galaxy and that we all revolve around the sun. So go ahead, Steve. I know you want to say.
Well, do you see now though that this was way back when, back in the 50s, and a lot of the science fiction writing was going on. Now, again, I think Velikovsky was trying to make an argument. I just don't know what it was because he was a credible scientist at the time. But the whole comment from Saturn thing still throws me. I'm not sure what his reasoning at all was that for that was. But I mean, we understand now that Saturn was never a brown dwarf. It's not even close to a brown dwarf. We understand what brown dwarfs are. The Saturn doesn't have the composite necessary composition to be a brown dwarf, nor the temperatures to be a brown dwarf, nor the size to be a brown dwarf. If I remember correctly. So, we would have to, see that, the Earth itself as a satellite, to Saturn, to have some cataclysmic event that would eject it from Saturn's orbit, and all of a sudden, arrive somewhere between, Mars and Jupiter, where we're now at. It just isn't physically possible.
Look,
I mean,
I know
that.
I know full well that you see this entire thesis as absurd.
Right.
And I know that it's not easy And I'm not saying that I'm 100% on board. It seems to me that a lot of things seem to line up along in support of this idea. And I know that you said that Saturn doesn't have the size according to mainstream physics, but I'm not necessarily going against or going with mainstream physics, and I'm not necessarily the guy specifically to argue against mainstream physics. Like I said, please reach out to Walt Thornhill. There's nobody better who can represent these ideas than I can. But it does
Well,
seem.
what makes you think Thornhill is correct? I mean, what makes you think that the electric universe has any validity to begin with?
Well, from an observational standpoint, I think it would be hard to argue that literally everything that we observe is in fact electrical. Our bodies are electrical. Chemistry is electrical, right? I mean, chemistry doesn't happen without electricity. The sharing of electrons between oxygen and various other elements is what we call oxidation. The oxygen atom is
Well, no,
what they.
oxidation isn't sharing. Oxidation is when you have oxygen taking electron from something else.
That's what I
You
mean.
have
That's sharing.
oxidation.
It's taking
Well,
an
no, it literally
electron.
takes it. It doesn't share it. When you have a sharing, you have a bonding, like ionic or covalent
Okay.
bonding, right? So
Okay.
it's not
Pardon me.
sharing electrons.
Okay. All right. All right. I used the wrong word. I don't mean necessarily sharing, but
Electronegativity deals with sharing of electrons. And when you have like fluorine, it's
okay.
like
But
highly electronegative.
oxygen is considered caustic, and it's because of that principle that oxygen will either steal, usually stealing or taking electrons from other elements, and we call that oxidation. And so when I say sharing, I mean, well, I had it and now you have it. Okay, so if I'm an iron molecule and you're an oxygen atom, um, maybe sharing is the wrong word, but you stole an atom, or you stole an electron from me. So that is the movement of electrons. That's what we call electricity. Yes, is that correct?
Yeah.
I mean,
Yeah. When you
am I way off?
no, when you lose an
So
electron, you oxidize. When you gain an electron, you reduce.
okay,
Leo
exactly.
goes
So
grr or oil rig. Yeah.
okay,
Oxygen
okay,
is
thank you.
loss. Reduction is gain. That's how I remember it.
Okay, all right, right. Look, I'm well aware that you're better versed in physics than
Oh,
I
I'm
am,
not. No,
and
I'm
so
I'm
I
really
will.
not. Dude, I'm going back a lot of years in this, dude. I graduated nuke school in 1989, and I took physics again in 1993 to 95. So I took science courses. So maybe I
Okay,
took
so
one in
back.
2000.
So all right. So back to the point. The point is that chemistry doesn't happen without electricity or electromagnetism, and I hope and I think that you would agree that magnetism does not happen uh, without the movement of electrons, without electricity.
Well, you could no.
Electricity is,
Well,
well, we
I
have
think you can have
permanent
magnetic.
magnets.
Yeah,
We had,
exactly.
all right, there are permanent magnets, but let's go back.
Neodymium magnets don't have electric current going through them.
No, I understand, but how was um, a neodymium
Lithium.
magnet created? A neodymium magnet and all other magnets are created by the use of electricity. You need electricity to create a permanent magnet.
Not
So we
necessarily. You
have
could.
magnet.
Never mind. But I think there's some other ways as well.
No,
But go ahead.
well, okay. Well, I mean, I'm willing to be enlightened. If there are other ways to create a permanent magnet, let me know.
Well, permanent magnets. The thing with permanent magnets, nothing to me is actually permanent. Magnets tend to lose their magnetic flux over a period of time. Even natural magnets do, but you can have like in the side of the Earth, right? We have liquid molten iron that's moving around, right? It's producing this magnetic field, correct?
Hang on, stop right there. Yes, I understand the concept. I totally understand the mainstream physics. We have a liquid core that creates our magnetic field. However, what I have a problem with is how does liquid metal make a magnetic field? What is the
Well, you have
principle that
you have
allows?
Lenz's law.
Lens law?
Lens law, yeah. Right hand current. You have current moving through a wire this way, then your magnetic field will be going around this way. Where's the left hand law? I'm trying to show you guys like the left hand, right hand laws. I forget which one's which. It's the right hand law for current flow, isn't it? This is why I need an actual.
Right.
I don't remember. Is it the right hand law?
Yeah, it's right hand. So if current is flowing away from you, if current's flowing away from you, i.e. the negative side is closer to you physically and it's going that direction down a wire, cross section is going to be to the right. So that it's going to, the magnetic field is going to go clockwise.
Clockwise, perpendicular to orthogonal to the direction of flow of current. Yeah, we're making us go back and remember basic stuff here. Go ahead.
All right. Well, I'm not trying to deflect from what we just now got done talking about. But you asked me a question a moment ago. What makes me think that, what makes me believe or think that the electric universe thesis is correct? So I started with chemistry, basic chemistry. Then chemistry doesn't happen without the movement of electrons, the stealing or sharing or borrowing of giving or taking of electrons, the movement of electrons. We call that electricity. That's chemistry. And then you move up the scale to, say, biology. And as human beings and living entities, we know full well that our bodies, as well as all other living things on Earth, are electrically driven. Our brains are electric, our nervous system, and inside our bodies as chemistry is happening inside our bodies.
Well, I mean, it's not just electrical; it's chemical, electrical processes, right? I mean,
chemical / electrical.
Well, there's physiochemical, and there's chemical electric. But the electricity is an actual flow of electron. Well, it's actually a flow of whole of electrons. When they discovered electricity, they thought that electrons were flowing through like a wire, right? They thought that like lightning was electron flow from clouds to the ground. Come to find out, both of them are not really correct. Lightning actually strikes mainly from the ground up with liters, and then from the cloud.
No,
but it's not actually electron flow. It's whole flow. It's a lack of electrons actually flowing.
Well, there's an attraction between the upper atmosphere and the lower atmosphere, i.e. the ground. And if you look at a super high-speed image or video, super high-speed video of lightning strikes, you can clearly see that the massive bolt of electricity does, in fact, come down and flows down.
Right, but liters come up.
And yes,
right, but liters come from the ground.
Yes, there are liters that go up to meet it. Yes. And then on top of that, I hope that you don't forget that there are sprites that happen above the clouds that vent out into space. Sprites and elves, yes.
Mm-hmm.
Okay.
And there's also a new one called Steve. That's the name, Steve, literally. Not lying. Go look. It's a new phenomenon, new atmospheric phenomenon called Steve.
Called Steve.
And I'm not making this up. I'm really not.
Okay, so back to biology. You said it was electrophysiochemistry. So we have already established that chemistry is an electrical process. Biology is an electrical process. Even though there is chemistry happening inside our bodies, which is an electrical process, but we also have a nervous system that runs entirely on electricity.
Okay. Let's just grant arguendo that a lot of it has to do with electricity. Electricity exists, but when you're talking about electric universe, how does it relate to like the sun? How does it relate to like Birkeland currents, which again I fully admit exist? There's a whole bunch of different currents in the ionosphere, but in magnetic sphere. But so how does that relate to gravity? How does that relate to strong nuclear force? How does that relate to the weak nuclear force? This is where
this is where you need to talk to Wal Thornhill. Now you're getting into realms of technical discussion that I probably can't handle. So I mean, I can go through my presentation and I can show you slides of craters that are impossible by impact, and I can show
that's not true. That's not true. Well, we say impossible. I've looked at your craters thing, and do we have a slide of that, Dave?
No. You looked at one slide of one. You looked at one picture that was accidentally injected into my astrotheology slideshow. You looked at one slide. You haven't seen what I have for you tonight.
but I've looked at other slides of dual craters, and the cause of that is not because of electric arcing. The cause of that is you have a debris from a comet or meteor, usually I believe it's comet, that come in at very similar trajectories at the same velocity, and so they're striking at the same time. There's a coordinate between both of them, so when they hit together, the shock waves at the middle meet, making that ridge that you see.
I will grant you that if two comets of equal or near equal size, two debris, two asteroids, whatever, if they strike at nearly the same size and nearly the same velocity, and they strike at literally exactly the same moment in time, then you can get a straight line between the two. I will grant you that physically that is possible. I'm not saying it's beyond possibility. Now, can you tell me, is there ever an example or possible? Is it even possible that a single asteroid could strike any object or body in the universe, or planet or moon, at any time? Is it ever possible that an asteroid would leave a hexagonal crater?
Well, when it comes to these things, who knows? There's a hexagonal weather formation on the pole of Saturn, right? That they didn't understand for a very long time, right?
We're gonna get to that. Absolutely, we're gonna get to that.
But yeah, things can happen. Real quick, things can happen, right? But like, for example, during the lunar eclipse, there was actually a strike. There was actually a photographer that actually captured a piece of debris hitting the moon, and having a light. I mean, we know that things do strike the moon. How is it that something we know exists? We know that the moon has been struck by objects, but the electric universe posits that these are from electrical arcing. But we've never seen that.
We have seen it. Many of them are from electrical arcing. I'm not saying, and they being the electric universe people, all of the people involved with the electric universe or thunderbolts, they're not saying that all the craters are electrical arcing. There certainly are, without a doubt, impact craters. No doubt about it. No doubt about it. I mean, I have personally been to Meteor Crater, Arizona. I've seen the vitrification. I've stood on the edge of that thing. I've walked down inside the crater partially, as far as they let you go, and I've taken pictures of the vitrified, boulders that are still there, and no doubt, absolutely, you can tell as you approach this crater that the side walls have been pushed up. It's got a bowl shape.
Glass. It's definitely from meteorite.
But you know what it does, and they have also found the nickel iron core. It's sitting in the museum. They found that nickel iron core at the bottom of that crater. So there's absolutely no doubt that impacts happen. But my big question is, an impact crater leaves a bowl shaped. Okay, it's rounded all the way down, all the way around. It's very rounded. That's an impact crater. First of all, it does not leave a hexagonal crater. And second of all, it does not leave a flat bottom, a shallow crater with a very shallow flat bottom with a peak or a mountain, or otherwise, for lack of a better term, a nipple in the center. Impact craters don't.
They do. No, that little thing in the center, impact craters will leave something like that. It's as the wave comes back and comes back up like this, I believe.
Okay, has that ever been observed?
Yeah, they've shot pellets into like a fine sand, and they observe the craters being produced there.
Okay, I would urge you to
high particle bullets.
I know what you're talking about. That lab where they have that super high velocity gun that they shoot into various substrates. I would love to see an impact crater that displays the nipple in the center. If you can show me that, either show it tonight or email it to me, I would very much love to see an impact crater create that anomaly. Very, very much like to see that.
I would have to look into that. I'm trying to get George in here. George says he might be able to help on a lot of this because he's an actual electrical engineer but his email isn't.
Well, I
going
tell
through
you
to me
what,
for
if you
some
don't,
reason.
if can I have a 45-second break? I need to run to the restroom. I've had 3 glasses of
Yeah, of
wine
course.
waiting for you guys to work out your technical problems. So I'll be right back. Give me a couple seconds.
Yeah, why do that? That little nipple is that little peak in the middle. It's a little island in the center of craters formed on the moon. Like if you look at Tycho, you'll see the obviously the crater, and then at the very middle, you'll see this little island peak. Now, what causes that? What the physics behind that is? Somebody like George would have to explain that. I don't remember the exact physics that makes that last minute thing come up after the impact. So, but if we can get George in here, that'd be great. Did George just get timed out? George, did George time out George? What's going on here? Why did George Mayer time out George? Oh, different George. No, not that George. George Newcheck is what I'm looking for. Different George. Team Skeptic might be able to help. Well, I mean, if you're interested in this topic and you know a lot more than I do, again, this is not an area I'm that familiar with. So let me know, and you can message me via direct message on G Plus or send me an email. Okay. Continue on.
All right, I'm back.
I'm trying to get a hold of George Newcheck, but it's difficult.
Okay. So Dave, okay. Let me see. Hang on. I was waiting for a new. There it is. You know what? We've been chatting away, and I should have did this while I was talking. Open.
Yeah, Daryl Frost
share.
says it's a reflection.
Dave is waiting for my whole.
Sorry, we have a huge lag here. Yeah, we have a huge lag here. David Frost says it's a reflection of the compression wave. Yeah, and that's what I kind of figured. You have you have a wave coming out, it's compression wave. Then you have a reflection coming back, and it's going to cause a little peak in the middle. Go ahead.
I sent George a link, by the way.
Oh, did you? Okay, good. Thank you.
Okay, Dave, I'm sending you my presentation right now, and it's about halfway uploaded. So, in just a few more seconds, you should have that. It's 72 out of 96 uploaded, 83, 87. So you'll have it in a couple of seconds. I should have did that while we were talking.
No problem. We'll get that taken care of. So to continue on, I mean, we like you said, you've said that you recognize that the moon gets struck by meteors or comet debris.
Yeah,
the Earth has many times as well. You know, and I know we can't explain the island in the middle that's on Tycho and stuff like that. I do know that there's physics behind that. I'm just not familiar with it enough to explain the physics probably as well. Somebody like George could, who maybe when he gets in here, he can do it. But the point being is that we know this is not due to electrical scarring, right? We do know that electricity exists.
No, I would argue that we don't know that.
Why? When have we ever observed arcing between the Earth and the Moon?
We have probably never observed arcing between the Earth and the Moon, unless maybe. Unless, look, the only observation of any arcing between planetary bodies is going to have to be deep inside of mythology, which is not something that anybody is going to rest their laurels on. I'm not going to die on that hill. All I can tell you is that there is an incredible congruency between all of the stories from all the cultures from every continent all the way around the world that are showing petroglyphs and hieroglyphs and talking about a time when they were observing things in the sky, and their petroglyphs are stunningly identical.
Like you're talking about Squatting Man.
Squatting Man is the one of them, yes. Is probably the main one, yes.
Yeah, I'm not seeing the correlation here. If there's a correlation between pictographs, okay, great.
Well, Well, as soon
Right.
as my slideshow opens up, I can share with you some images that have been taken from plasma discharges in laboratory and comparing those.
Yeah, I've seen
Uh,
them. No, I've seen them all. But tried to read the paper on that. It's not an actual paper. It's something from the Thunderbolts project. It doesn't have a methods section. It doesn't tell how they made the plasma discharge. It doesn't tell if they made something similar to the pictograph to see if it was plasma would conform with it. It doesn't tell how they did any of this. It's vague beyond vague. I can't even do any reading on it because there's nothing to read. The only paper, like I said, and I use a paper with air quotes on it, had no methods section. And it's from the Thunderbolts project, so it doesn't really tell me anything non-opinionated, anything non-biased. So I can't find any corroborating evidence to support any of this.
I don't even
Because I
know
don't know
how
how they
to
did the
respond.
experiment.
I don't know
Well,
how to
have
even.
you read the paper?
No, I have not read their papers. No, I have
Then how
not
do you
read
know
their
what
papers.
they? Okay, well then you say that they did these plasma experiments and they have these discharges, but if you don't know how the experiment was done, how do you know if it's even a viable experiment? Because I can't find anything that's in their data. The data doesn't suggest anything besides, hey, this is what this figure looks like. This is what the pictograph looks like. That's all they did. They don't explain how the experiment was done. They don't explain the actual details of the plasma discharge. They say, oh, well, this part of the plasma discharge is the diachronic, diachronic
Dendritic.
instability. Which do you know?
Okay.
You know what the diachronic instability is?
No, I thought you were going to say dendritic, but go ahead.
No, diachronic, diachrotron. I don't know how to pronounce their words. It's a diachrotron instability. Is for I've looked in it before. It's based upon the Kelvin-Helmholtz instability. In fluids, you have laminar and you have turbulent flow, right? And between these layers, you will have a shear force because of friction, and that shear force will cause these little curls to be forming, right? So it's called the Kelvin-Helmholtz instability in fluid mechanics. So that formation is something we do see in clouds. We see it in fluids, but why they give no instance of why we actually see this in this plasma thing that they're looking at. They're saying, look, it's exactly like this pictograph that we're looking at. So that's why I kind of want to get George in here. Maybe he can add some better understanding to that, because I don't know what their experiment exactly was entailing. Dave, can I get another link for George? He said he has not received one. And I'll get it to you, Dave, in a minute here.
Yeah.
Or the same link. Just give me his link and I'll get it to him in the email. But go ahead. I mean, do you know what I'm saying? If you look at that diagram that you showed,
I do
like
know what you're saying.
silver.
I do know what you're saying, and I noticed that you are talking about fluid dynamics, and we're talking about plasma. Plasma doesn't.
Yeah, but that behaves like
plasma
fluid
doesn't.
dynamics.
Not exactly. It's not a fluid, and it may sometimes display waves within it that are similar to fluid dynamics, but plasma is clearly not a fluid, and it does not have the same properties of a fluid.
Well, I disagree. Plasma would be a fluid. Why wouldn't it be a fluid? It has fluid. It adheres to fluid theory.
Why wouldn't it be a fluid? Why wouldn't plasma be a
plasma is just an ionized state of gas, right? But it obeys all the laws of a fluid. I mean, if you can put the
not exactly. Are you familiar with the colloids?
Colloids, yes. A colloid is suspension of something in a solution that has bigger size than a normal homogeneous solution.
Okay, well that occurs by that occurs by electrical charge. It doesn't occur by fluid dynamics. It doesn't operate the same way as that big vat at the fair with all those plastic balls that represent. You could think of it as representing atoms or molecules of water or fluid. It doesn't behave the same way. It behaves in a way it's more conducive to electromagnetism. They're suspended by their own distance from each other. It's like, go ahead. Okay.
Well, I agree with you. Because plasma has a charge, right? Because it's an ionized gas, it flows, and if it flows, it's a fluid. That's why plasma is categorized as a fluid
All
and
right.
adheres to fluid theory.
Yeah, it has properties
I'm not saying it's a liquid.
fluid. Okay.
No. It is a fluid. It's not a liquid, right? Liquid, gas, solids are states of matter, right?
No,
Plasma
I
is another
understand.
different state of matter that falls under fluid. There's also Bose-Einstein condensate, and they think they might have discovered another one recently, a few years ago, but I don't remember this name.
No,
But
I'm not actually. I'm
yes,
not
plasma
actually
is a
arguing with
fluid.
you. Okay, I'm not actually arguing with you. I know that the plasma it has properties of a fluid.
No, not just
But
properties of a fluid. It is a fluid. I'm pretty damn sure of that.
okay, well,
I'm looking at the live chat right now. I'm trying to get George. I'm trying to do this and send George the link at the same time. So I'm a little discombobulated. Please forgive me because I got three things going on at once. But yeah, from what I remember in fluid theory and stuff like that, plasma is definitely a fluid. It's just not a plasma. I mean, it's just not a liquid, right? But it is a state of matter. Oh,
By the way, is this correct folder, Aaron? Is this the one you
yes.
wanted? Okay.
Well, that is one of the images in the file that I sent. Now, real quick, Dave.
Well, there's folders. There's multiple folders in here, so I kind of need to know which one you want to display right now.
Oh, okay. See, that's interesting because when you were not here last week, Kyle downloaded mine.
There's a whole bunch of them in the root as well. So, like, do you want just the root folder that you set up?
I tell you what. Let's go. Let's just go to the. I'm hearing a clickety click. Okay. Let's go to the double.
Yeah. Okay.
Let's go to the double. All right, let's go to the double comet in lab experiment folder.
Okay, give me a second.
Yeah, people in the live chat, just real quick. Not modern glass, old glass, like back in the 1800s. Old glass, the way it was made, was technically a fluid because it flowed. If you look at some of the old panes, it tended to kind of
they
settle
thicken
down
at
to the bottom and be bulged. Yeah, thicken and bulging at the bottom because it was just a very, very high viscosity fluid, very viscous.
Correct.
So technically, those things are considered to be fluids in physics, but for all practical purposes, they are solids. So it really depends on your definition. Technically, anything that can flow is a fluid. So if you really wanted to be a pendant, then old glass was a fluid.
Sure.
Like honey is a fluid, but modern glass is not made that way. Modern glass will never have that.
Sure. Yeah, it's just a matter of playing with semantics.
Falling down the bottom.
Yeah, you're totally correct. I agree. I'm familiar, and you're totally correct.
Although they say old glass flow is a myth, but I don't. Is it a myth? Really? Are you sure about that?
I don't think that's a myth. I think it's correct. Some of the cheaper, and by older, that's getting into semantics because the Egyptians were working with glass and they knew what the fuck they were doing. They had an amazing ability to work with glass. So I mean, I've been.
Iogismo says is a myth, but when I look at the physics forums, they say it's not a myth. So the pop science says it's a myth.
Okay, so this first image we're looking at is Comet Hartley 2. And the first thing you'll notice is that it is a double ball. It's got this weird neck that is very smooth and craterless and featureless. I'm hearing a real scratchy, clickety thing. I don't know.
Yeah, is that Dave?
Yeah, I'm sorry. Let me mute.
Can we figure out if George is working here? George?
I asked him in the live chat if he has a webcam and is using his mic, and is using because
he says not recognizing the camera.
Well, there's always Skype. We can do that.
All right, you go ahead and work on that with him. Yeah, use Chrome, George. That's usually solves the problem.
Okay, so I know that Dave is busy, but I'm going to need Dave to move through the slides for me. And I realize that he's busy trying to get George in here. But the first image that we have here.
You want to go to the next one?
Yeah, go ahead and go to the very next slide, which is, go ahead. So this is Comet Hartley 2, which not only has a double lobe, which has a strange neck-like feature, which featureless, by the way. But if you see the image to the right is an experiment that was done by, I think it was David Peratt. And the ball up in the top right corner, I'm not sure if I have a super close-up. Not sure if Dave, can you even, is it possible for you to zoom in on that image? I'm not sure if I've got a closer image. These are electrical discharges that were conducted in a laboratory. Zoom in and go to the upper right thing. Let me get rid of this side chat. There you go. I think this is, if I'm not mistaken, this was this is hematite. Then electrical discharge in a hematite created this little spheroid, which was a double ball. It's exactly like Comet Hartley 2, almost identical in form. And then what we've discovered is, Dave, you can go ahead and go to the next slide, and then go to the next one right after that. That there are multiple comets. We've got Ultima Thule, and we've got let me see, it's Comet 67P. Go ahead and click to the next slide, Dave. So here's just an example of many multiple comets that have this same similar structure. Go ahead and go to the next slide. I think this is an image of 67P. Go ahead and go to the next slide. This is Ultima Thule, another comet with exactly the same structure. Go ahead and go to the next slide. Another double lobe. This is Comet 67P compared to the image that I tried to show you that I asked Dave to zoom in on. So the one on the left was created in a laboratory with, I think it was hematite, and compared to Comet 67P. Go ahead and go to the next slide. This is a close-up of Comet 67P. Dave, jump over 2 slides. Go 2 slides over. 6.7.1. Here we go. So what I've done here is I've highlighted some of the features that should be noted here. Circled in red is what looks like electrical machining. In the blue, on the bottom left, I've got 4 arrows. Sorry, I was using my mouse to draw and write the word hex or hexagonal, because if you'll pay close attention to what we have are hexagonal craters. So there's a double crater. The top left one is a hexagonal crater. The next 2 down are a double hexagonal crater. And then the one in blue that goes all the way over from the left way over to the right is another hexagonal crater. And then, Dave, if you could scroll up slightly, there is I noticed an odd, what looks like a drill hole. And at the very, very top center of the screen, you can see the arrow. There it is. It's a very strange drill hole. If you zoom all the way in on that drill hole, you see concentric circles. All
Yeah,
of these things
I
have
don't
been.
see hexagonal. First of all, I don't see hexagonal craters. I see very old craters that have been bruised and battered and beaten and worn, but I don't see anything hexagonal.
All right. All right. Well, then I'll ask Dave to go ahead and scroll to the left, go back and get a better look. I'm sorry. I then scroll right. Go. I want to see to the left, so scroll right. Up. Go to where the blue arrows are pointing. They're not perfect hexagons. They're kind of like the hexagons that you see at in that place in Ireland. What's it called? Devil's Causeway. But those are clearly straight edged. The one on top is without a doubt. It's almost a perfectly formed hexagon, and the one below.
I think you're under a false presupposition here. You're assuming that they were made that way rather than not a crater that's very old and due to erosion, and somebody mentioned outgassing because it's a comet, is going to cause these eroded features on these things. So they're not going to be pristine circles anymore, even close, because the crater's not pristine to begin with. But you're going to have erosion on the walls and outgassing. These are very, very billions of years old, some of these.
I will grant you age and I will grant you erosion. But this one that we're looking at right now is quite clearly very sharp-edged, very distinct hexagonal pattern with almost perfect 120-degree angles.
I could definitely see something similar, but again, so what? That's just pareidolia. There could be a couple different reasons for it. You could have density.
I hear you.
In the stratum, you can have just the way to erosion. Yeah, I mean, I don't see anything that's really important about this particular feature.
All right, Dave. Let's go into the Mars folder. Inside the Mars folder is
one sec, real quick. Dave, can I get your Skype ID in the internal so I can get it to George?
Steve, I hear you. When it comes to pareidolia, I hear you. I totally get it. I know that people see things that often are not there. I'm going to show you a whole shitload of craters that are there. There's just too many to dismiss as pareidolia. I mean, if there was one or two here and there,
what folder am I taking to again now?
Dave, go inside the Mars folder.
Okay.
And then there's a subfolder called hexagonal craters.
Okay.
All right, I found a study actually that is pretty much kind of similar to what I was even saying about the stratum, that actually explains hexagonal craters on the moon. And I'll read it to
tell
you.
me.
I'll put in the live chat.
No, go ahead.
It says possibility of impact. This is from astronomy, Harvard University. The possibility of impacts of large meteorites on the thin crust of the early moon accounting for the formation of the hexagonal lunar craters is discussed. Solidified basalts comprising a lunar crust of thickness of 10 to 15 kilometers, characteristic of the early stages in lunar evolution, are shown to have large-scale hexagonal pillar structure due to the effects of shrinkage. Effects of the experimental simulations of the propagation in this hexagonal pillar structure of the shock wave generated by the impact of a meteorite of a diameter 10 kilometers and mass 10 to the 15th kilometers on the lunar crust are then presented, which demonstrate the pushing away from the central circular shock of pillars resting on a low friction surface in a hexagonal pattern. This is what science does. Science seeks to explain these things in ways that are demonstrable. So this paper here
that sounded like word salad. It didn't sound demonstrable. And by the way, you mentioned the word.
Hang on. You were reading that. I can't let you say that because this is actually from Harvard University from 1991 called A New Explanation of Hexagonal Shapes and Lunar Craters. That cannot be word salad or would not be a peer review paper. Word salad means that somebody's saying things, just throwing out words that doesn't have any real meaningful or cognitive meaning to that at all, right? It was just basically jumbled up garbage.
Could you just read the part again where it discussed shrinkage? I didn't understand that part. How does shrinkage play a role in hexagonal craters?
because if you have a stratum that for whatever reason starts
For
getting
whatever
smaller,
reason,
whether it be water vaporage, outgassing. I mean, you have 4 billion years or billions of years of some kind of effects on this particular, body. In this case, the moon. The moon's been around for several billions of years. I don't. I would have to actually read the paper to show what actually is being demonstrated. But you can't just say it's word salad without reading it more. I mean, that's just is just argument from the stone.
well, I have
Because
to say,
these,
no, go ahead. Go ahead, finish.
I was just going to say that there's always people trying to give scientific explanations for something. This is a peer review paper from Harvard that explains it, right, or purports to explain it. Thunderbolts Project has not a single solitary peer review paper to explain any of these phenomenon that I'm aware of, not one. Why is that? If they had any legitimacy whatsoever, scientists would be going, hey, there's something to be said here. We can demonstrate this. We can demonstrate in the laboratory conditions. We can show that this hypothesis has value. But no reputable scientist I've ever met takes electric universe theory seriously, because they have not a single peer review paper where they show the method section of how they came across these things and they came to these conclusions that it was all electric. Doesn't that strike you as odd that not one of them has published on this topic?
I don't know. I can't say whether they have or don't have peer review papers. I can tell you that Wallace Thornhill is constantly talking about papers that he publishes. I don't know how peer reviewed they are. I don't know what publications will allow him to publish or will publish his papers.
What do you mean
But I
allow?
promise
I mean,
you,
if the data is good,
well,
they'll allow. He doesn't publish, as far as I know, in reputable journals. He publishes in the Thunderbolts journals, right? They have their own journal that they publish. It's not even a journal; it's a publication.
well, he's not the only PhD on the whole project. This
It's
whole
PhDs in
consortium.
creationism that publish in the Journal of Creation. So what? Journal of Creation is not an actual journal.
Well, no, what I'm saying is that I promise you, Steve, I will absolutely get back to you. This is not just me making an empty promise.
I believe you.
I will absolutely, after this discussion, I will absolutely go headstrong into looking at whatever peer-reviewed papers that they do or don't have. I promise you I will get back to you. And if there is nothing that I can find, I promise you I will still contact you and I will tell you that, you know what, I looked my best and I couldn't find anything. So all I can tell you is these people are constantly, I mean, there are millions and millions of dollars into the Sapphire project and into the Thunderbolts project. This whole consortium of many, many PhD scientists working on this concept.
Yeah,
So
it's the Starfire project.
this
It
is
has yielded zero results.
Sapphire. It's the Sapphire project.
Yeah, Sapphire. Yeah, Sapphire project. My bad. Yeah, and what has the Sapphire project actually came up with that you're aware of?
What I'm aware of is that they have produced in the laboratory many multiple examples of plasma discharges that show the images that represent the same images that we see in cave drawings all around the world.
No, you don't, because they don't have a paper on this. What they have is a publication that they have that doesn't explain the methods by which they even came to those things. They don't even explain if they made a mold that looked like the pictograph to begin with, right? I mean, how do you know they didn't take the pictograph, make a mold out of it for some kind of arcing, and then put a high current through it to see if it would produce plasma? I mean, how does this you have to explain how this plasma shape came to be, right? And then there's no method section to explain in what I read any of it. It just says, here's what we produce in the laboratory, this plasma. Here's the pictograph. Oh, look, they look identical. Okay, how did you get from A to B? How did you produce that? Their writings doesn't explain any of that. And I looked. I really did look. In fact, I probably could find the paper again. Or paper. Let me see if I can find it again. While you explain this, what's on the screen. And
Dave,
here.
Dave, what we're looking at right now is a crater on Mars. Go to slide 2, 1.2. This is a closer up of that same crater. It shows hexagonal patterns all the way around that crater. Dave, go to the next slide, 1.3. This is a super zoom in. This is definitely, Dave, can you just zoom that up expand that out a little bit? This is the same type of hexagonal pattern that we see at the Devil's Causeway in Ireland. Again, they're not perfect hexagons, but each one of these formations has 6 sides.
Okay. Again, I'm not seeing the argument though.
Well, you're familiar with the North Pole of Saturn, which is a giant fucking hexagon.
Yeah, and they're just now beginning to understand what's causing that.
And what are they saying is causing that?
Oh, it's whatever the wind conditions are for the shear forces. I don't remember the details. I
Okay.
could probably look into it though. But basically the wind patterns causing
Yeah.
the shear force on. But
Well, that seems. I know that you said you haven't looked into it, and your explanation so far seems super simplified. Okay, the wind patterns. The wind patterns don't explain how they're moving. What are they moving? Something like 300 miles an hour, and somehow they make a 120-degree turn, and then they go straight, and then they make a 120-degree turn, forming a perfect hexagon at the North Pole of Saturn.
Yeah, why not? I mean, it's turbulent flow, right? I mean, you're going to have
why
instabilities in that flow. Yeah, I don't
Okay.
see. You have an argument from incredulity.
So my question to you is, wouldn't it be easily explained by an electromagnetic field?
No, I don't think so. I mean, I'm going way back here in my fluid theory. I took fluid theory, obviously, in nuke school, so it's way out of my depths here. But you definitely can have if you have different vortices forming and you have different differentials due to shear force and friction and boundary conditions, then if you have these changes in viscosity at certain points, then you can have different shapes appear. I mean, I don't see it being, like amazingly complicated to kind of grasp that wind patterns can cause something like this. I just know the math behind it, right? I would have no idea to be able to demonstrate this mathematically.
So are you just dismissing out of hand that an electromagnetic field would not be responsible for that?
No, but from what I remember reading, that they've determined, and this wasn't that long ago, like 5-6 years ago, that they have researched it, and they've determined that it's because of difference between turbulent flow and well, I don't know how much laminar flow is laminar linear flow, but there's definitely turbulent flow going on there, right? I mean, you would agree, right? You got a rotating body. You have.
I understand fluid dynamics to an extent, and I understand eddy currents pretty damn well. And I understand that eddy currents by themselves can, in fact, create straight lines.
Well, eddy currents would be more hysteresis-like losses and like a iron core, right? You have these small rotational.
Yeah, you're talking fluid dynamics.
Yeah, same principle. I'm still trying to get George in here, by the way. So I am listening.
Okay, Dave, jump over to 1.4, please. 2 slides over. 1.5, actually. 2 slides over. This is a ferrofluid. This is a image of ferrofluid under magnetic field. Hexagonal patterns. So magnetic fields have been shown to create hexagonal patterns.
Yeah, and it's okay, and I'm not discounting that by any stretch of imagination, but you're seeing a similar result and describing it to 2 different phenomena. 2 different phenomena can produce similar results.
But is okay? All right, Steve. Is electricity?
And by the way, these are
in your mind, Steve? Is electricity scalable or not?
What do you mean scalable? Electricity is the flow of holes in a wire, or in a some kind of medium, like from higher concentration of ions or electrons to a lower concentration.
Okay, I'll rephrase a little more specific. Is electrical effects like arcing and the effects that we can visualize, like what we see here, is it scalable or not?
Oh, you're talking about like supervenience, where you have something at the lower levels will produce something similar at the higher levels?
Yes.
Okay, yeah, that's called supervenience. Sure.
Okay, so you acknowledge that electricity and electromagnetism is scalable. What I'm showing you here is ferrofluid under electromagnetic field showing hexagonal patterns. Dave,
Yeah,
jump
and
backwards.
we also see carbon that forms buckyballs, right?
Yes.
So we see various structures, but you have to show that you have to show that Saturn's hexagonal nature is caused by this, when scientists have showed that it has nothing to do with ferrous material or magnetic fields. It has to do with wind velocities and changing of wind velocities and the differential of wind velocities within the system. And I'm still
Okay, but
frustrating atheists
when
can
we're
get in if
but when we're talking about, like, for instance, the North Pole of Saturn, I don't know what the distance is between straight line and straight line, but if I remember, the winds are supposed to be moving at something like 300 miles an hour, making those turns,
yeah, sure.
roughly 120-degree turn to make a hexagon. And I don't recall the distance on each of the straight lines, but it's many thousands of miles. It's perfectly straight. So in fluid dynamics, it's hard to explain how that pattern can maintain itself.
Well, I don't think it is if scientists are able to explain it. I mean, you have, again, your argument is from incredulity here, right? Because you don't know what the scientists have said. You just say it's hard to explain.
Fair enough.
I mean,
Again, Steve, I'm not a physicist. I mean, I'm doing my best to represent the EU. I'm not a physicist. I can't answer all your questions. Okay?
No, I get that, but you're representing the EU as this is a viable EU hypothesis, right? And
From
by
what
the way, they've done modeling of Saturn's atmosphere and produced the exact same results in computer models.
I've actually
So,
seen modeling. I've actually seen modeling in an actual fluid that recreated a hexagonal pattern.
well, yeah, Saturn's a fluid. Gas,
Dave,
right?
jump backwards one slide, Dave. 1.4. Now, Steve, is that a hexagon or not? Is that pareidolia?
Well, I mean, it's hexagonal like shape. I mean,
Okay, it's hexagonal shape. Okay, it takes on the shape of a hexagon. Now, Steve, look at that crater. Is that a bowl-shaped impact crater to you?
yeah, that's definitely what I would expect from an impact,
Really?
not an arc. Yes, really. That's what
Doesn't
craters
that
would do
seem
when you have a
for
compression and
for
reflection
the
wave
for the
and
size
erosion?
for the size of that crater? Doesn't it seem a
It
little
was a
shallow
huge
to you?
impact.
Yeah,
No,
it would be a fucking huge impact. I mean,
no. I
that
mean,
looks like it
first
would
of all,
be, you know,
what is Mimas?
15%.
I don't know. I don't know what his composite is. I don't know what a substrate is. I don't know any of the physics behind this to actually make one determination or another. But the shape, what I expect from an impact.
Okay, look at the crater above it. Is that a hexagon?
No, not really.
You
No.
don't see at least three very straight lines and 3 or 4 very sharp angles?
Yeah, stretching my limit of imagination, I guess.
Okay.
But
All right, fair enough.
but
Uh,
but I don't go by what things look like, right? That's how you get into mistakes, right? You don't go by. In fact, I mean, I'm looking into the whole glass thing. People said it's a myth. It might be, but because I want to make sure I put out misinformation. I might be wrong on that. But I wasn't talking about the medieval ones. The medieval one says the medieval one's a myth. I was talking about the ones in old saloons from the 1800s, and I'm still looking into that was a myth or not, because I don't think those were installed that way. The medieval ones, sure, I can agree that that wasn't the case. But everything I could find on the myth of the glass is on medieval ones, but not by the bars that in the 1800s would have that glass. So maybe we can look into
Dave,
that. But again, you can't look at something and go, "This is the case." You have to understand the science behind it. And I'm not a planetary physicist.
I hear you. I hear you. You can't just look at a single image and say, okay, boom, this is my conclusion. I hear you. Dave, jump to 1.6, please.
Hang on a sec.
Oh wait, we got George. You worked. Yay!
Oh gosh, Microsoft, I could wring its neck. It forced me to update Skype in my system.
Oh,
So I had to
man.
take everything down.
I have to reload
Yeah.
Skype every time I restart my computer. I have to reinstall Skype every single
Yeah.
time I have to.
Yeah, it
Every
really
time
sucks.
I
Ever
restart.
since Microsoft took over Skype, it's been a real piece of crap.
Yeah. I'm not disagreeing with you. I'm not a Skype fan to begin with. I can't stand it. I use Zoom, and I'm not a big fan of Microsoft. I try to use Linux at all possible, which I'm going to have to get with Dave or somebody else in a couple of days to fix my Linux on this computer because I'd rather run that than Windows. But on my laptop, I put Cinnamon Mint on it. Never going to look back. It's great. It's great. Love it. Anyways, George, what do you got to say for some of this so far? I know you've been listening in. Like this particular stuff I've explained, is
I caught some of it, but of course I missed everything while the system was down and updating. But the thing that the primary objection I have with a lot of this electric universe stuff is it's really quite easy to show. Oh, are you talking, Steve?
No, that's just background noise.
But again, you can't look at something and go, "This is the case."
Oh, you've got the video. You got the video.
You've got the video.
Let's see. Okay, am I on now?
Yeah, you got.
Oh, okay. Well, it's really quite easy to show that the dominant forces in the universe is gravitational. I mean, this comparison, of the weak gravitational force compared to the electromagnetic force is traditionally done by what you do is you take an electron and a proton and you compute the electromagnetic force, electrostatic force between them at a given distance and the gravitational force, and you compare them. And it turns out to be about a difference of 42 orders of magnitude. However, if you go up, say, to the size of a billiard ball and separate them at a given distance and, say, put a coulomb of charge on the two billiard balls, you find that the ratio of electrostatic force to the gravitational force dramatically reduces and starts now becoming on the order of 10,000. And as you get into larger and larger objects like the Earth and the Sun, and you do that same sort of computation, now the masses are considered, are very huge. Like the sun, the mass of the sun is 10 to the 30th kilograms. The Earth is 10 to the 26 kilograms. And you start putting, a coulomb of charge on these and comparing to the gravitational force. Now, all of a sudden, the gravitational force is well overwhelming the electrostatic forces. And I have shown in a video that I made that if you look at the Earth and the Sun and you try to compute, or you do compute the electrostatic force that is required, the amount of charge that would be required, free charge on the Sun and the Earth, in order for the electrostatic force to equal the gravitational force that's holding the Earth in its orbit, the amount of voltage between the Earth and the Sun would have to be of such magnitude that it would just totally strip the atmosphere. You'd have continuous electrical discharge occurring between the Sun and the Earth, and we don't see that. And
do we not see that in the aurora borealis? Do we not see
it's not constant. Discharge? I mean, that is not an electrical discharge between the Sun and the Earth. What that is just the solar wind particles from a solar flare coming in and creating ions in the lower upper atmosphere. That's a totally different phenomena.
Really?
Yeah.
Yeah.
And
really,
it's just solar wind. That's why you generally only see them at the northern or southern latitudes, right? You don't see them at the equator because the magnetic fields are stronger.
Yeah, it's at the poles. It's at the magnetic poles.
Yeah.
Again, I'm not a physicist, but I have heard that the electrical or electromagnetic force is something like 38 billion times stronger than gravity.
I just explained that to you. I said,
gravity is
if you take the way that
well,
the difference, if you compare the gravitational force of attraction between two electrons
Mhm.
to the electrostatic
Gravitation.
force between them,
Wait,
at
did
any,
you say the gravitational force between two electrons?
yes,
Did I? Okay, go ahead.
the mass of an electron is about 10 to the minus 31 kilograms. The Coulomb force on an electron is 1.9 times 10 to the minus 19th coulombs. If you use the Coulomb force equation and you use the Newton gravitational force of equation and you compute the gravitational force of attraction compared to the gravitation or the electrostatic force of repulsion of two electrons, that ratio of the electrostatic force to the gravitational force is what you just said. It's 42 orders of magnitude difference. The electrostatic force is stronger by 42 orders of magnitude over the gravitational force. That's for an electron and a proton. However, now if you start getting into larger masses, macroscopic masses, like we're used to, say, take two billiard balls, put a coulomb of charge on each of them, compute the electrostatic force of repulsion between two billiard balls compared to the gravitational force of attraction, that ratio dramatically reduces. It ends up being on the order of effect, not 42 orders of magnitude, but more like 4 or 5 orders of magnitude. Then when you scale up to planet size, planetoids, then gravitational forces of attraction start overwhelming the electrostatic forces of attraction. And when you get up towards galaxies, the electrostatic forces of attraction pale. They're insignificant compared to the gravitational forces of attraction. The dominant force in the universe is gravitational between galaxies, planets, and these types of large, massive objects. There's so much more mass in the universe than there is free charge.
Okay,
absolutely
so
agree
now,
with that.
okay, so now you're talking shit that's way over my head, and I can't argue with it. So I'm not even going to try.
Yeah,
Well, but the thing with
actually, I
you is
did a
that
video on this called
Oh,
The Dominant
and
Force
by the
in
way,
the Universe.
and
If you
by the
go on my
way,
channel, you
by,
can go
by
through,
the way,
I take you through the mathematics
George,
to show you
George,
how this works
George,
out. The thing
George,
is, in
what's your
order
channel name?
for the Earth to be held in orbit about the sun by an electrostatic force of attraction due to an electric field rather than a gravitational field, it would require charges, free charge, to reside on both the Earth and the sun of such magnitude that you would have continuous discharge, lightning occurring between the Earth and the sun constantly. But we don't see that. The breakdown of air in the atmosphere at the surface of the Earth is about 75,000 volts per inch. If you have a voltage difference of about 75,000 volts, it will draw a 1-inch arc. Now, if you go over the whole atmosphere, say go over uh, uh, or the distance between the Earth and the sun, if you use the 75,000 volts per inch of the breakdown value of the Earth's atmosphere and scale that between the Earth and the sun to get the total voltage that you'd have between the Earth and the sun, and then use the capacitance between the Earth and the sun along with that voltage difference to get the amount of charge that would be free charge residing on the Earth and the sun, it gives you a value of electrostatic force of attraction between
Okay,
the Earth and the sun that is 5 orders of magnitude less than the gravitational force. So the conclusion is that what you have is that the electrostatic force to hold the Earth in orbit about the sun to equal what we know to exist with the gravitational force would require an electrostatic force 5 orders of magnitude greater than what we see that would cause the Earth's atmosphere to break down at 75,000 volts per inch. Since we don't see
Okay.
that, the conclusion is that electrostatic forces cannot be responsible for holding the Earth in orbit about the sun. There isn't a sufficient force of attraction that could ever account for the Earth to be held in orbit about the sun, because you can't get that amount of charge, free charge on the sun and the Earth to give you that kind of force without totally stripping away the Earth's atmosphere.
Let me ask you real quick. What do you think is the reasoning behind the Thunderbolts project? Why these people with legit PhDs are putting forth this hypotheses when, as you demonstrate, none of what they say can be true. It just cannot be the case given what we know about physics. I think I looked it up when that you said that gravity was like 10 to the 42nd power, strong nuclear force 10 to the 44th, 10 to the 45th power, weak nuclear force 10 to the 38th, 10 to the 37th, give or take, as comparison to gravity. Gravity is an extremely weak force, but as you astutely noted, as you have larger objects, when you have things like the size of galaxies and the size of things of stars, or especially compressed in a small area like a black hole, if the sun was down to about 3 kilometers and became a black hole, it would be very, very small, very, very dense. But so gravity would be a much significant force than anything else at that point, because it's the dominant force. So what do you think is the reason why these people want to posit that electricity is the dominant force in the universe? Just because they see things like Birkeland currents, why do they posit that these plasma filaments in the universe are dominant somehow over gravity? I mean, where's the physics that they have for that? Because they're actually a physicist, but they never seem to give any reasoning behind, one, why they're promoting this hypothesis, and two, the math that goes along with it. I've never seen it.
Yeah, there's a book that was written many years ago. I followed this guy by the name of Donald Scott, called The Electric Universe, and a lot of this Thunderbolts project, I think, is more or less launched from that. Donald E. Scott was kind of the father of all this, I think, back in the day. And then, of course, you have this Eric Dollard that has been around basically forever promoting this sort of nonsense. But yeah, I've been very puzzled about that too, Steve.
Well, look,
it's hard to explain. I really don't know. They go off, they have some sort of theory without any real experimental evidence to back it up. And I just don't see where, how they can continue on. But they why does flat Earth exist?
Okay, I'm not going to be put in the same category as flat Earth. I'll be happy to get the fuck out of here. I've explained to you guys I'm not a physicist. I cannot argue with you guys on the extremely technical aspects. Dave, if you would do me a favor.
What makes you want to believe in the electric universe versus Newtonian mechanics, for example, or Einstein?
Look, I am not denying in any way, shape, or form that Newtonian physics will in fact get you to the moon or to a comet or to Mars. Newtonian physics works perfectly if you want to send a rocket into space and go to a planet that's in motion or a comet that's in motion. You can do all the calculations. Newtonian physics will absolutely get you there spot on. I'm not denying that.
So what aspect of electric universe then, what are you promoting here then?
Dave, would you go to the Mars file? Go to slide 2.4, please.
give me
I mean,
one.
while you're getting there, this thing about
One, George. I
the
need
divots
some clarification.
caused possibly
George.
by electric discharge, you realize, I mean, you can show this sort of thing in sand with a large capacitor or whatever, but do you realize to scale up to the size of a crater like we see on the moon or in Arizona, the amount of electrical energy that would be necessary to do that? It'd be
I am aware.
astronomical.
Yeah, it would be astronomical, and I can't help it if it's hard for some people to get their head around the fact that sometimes these things happen.
But,
Well,
but
wait,
why
no,
why don't we see it constantly happening now? If it happened in the past,
Yeah.
as you and the Thunderbolts claim, why aren't we seeing these constant discharges now, even though we still see meteors entering into the Earth's atmosphere and crashing in the Earth and creating craters? Why don't
Well,
we
that's
see
funny. That's
craters
funny that you
being
mentioned meteors.
created?
It's funny that you mentioned meteors because to this very fucking, excuse me, I'm not going to drop f-bombs. I'm sorry. To this very day, to this very day, we are still receiving asteroids and comets and meteors from Mars that are clearly identified
Comets from
isotopically.
Yes,
Meteors,
and
excuse me. We are receiving meteors from Mars to this day that are identified isotopically that are clearly a Martian rock. Dave, go to slide
yes,
2.4,
no, I don't
please.
discount that.
Yeah,
I
we
mean, what
agree
does
with
that
that.
have to do with
Yeah.
electric universe? So.
Well,
Okay, I need
that.
wait. Everybody, stop for a second. I need clarification. You say 2.4. Everything in this folder has a name. It doesn't have a number. So which folder?
Okay,
And then
in the
which
Mars
number?
in the Mars folder,
Right.
it'll be 2.4. Most of these are labeled with numbers ahead of the title. It's 2.4. It's in quotations. River channel going uphill.
Let me tell you what I see. Okay, the one that's named 2.4 doesn't show up. I pick the entire folder as a slideshow. So which folder is this file in? First of all, is it Lab B images or is it hexagon craters and more?
It should be in the Mars folder. Hang on just a second. I've got the same folder open as you do. It's in the Mars.
Remember, I don't see the pictures. I simply see the folders. When I'm trying to add it to where I see folders. So which folder is it in? If it's just in plain old Mars, that's fine too. I can pick that folder.
Okay, it's in the Mars folder.
Okay.
There's a few images, and then there are 2 folders within that folder. So just simply in the Mars folder, I want number 2.4. It's a river channel going uphill, then downhill, is the title of that image.
I don't know why this didn't actually change.
Should be the 4th image in that set. It's almost 2 more. Next one. There it is, right there. This is a channel. This is an image taken of Mars. This is what is claimed to be a river channel, and as you can clearly see, it goes uphill and downhill twice in this image. This is not a river channel. This is not water erosion. And now, clearly, at the very, very top, near the top right corner, there is very clearly an impact crater. That is a bowl-shaped, round, deep, round impact crater, no doubt. But below that, this entire channel, starting from the very right side of the screen, there's an uphill, and then you go to the center of the screen, and there's a steep uphill, downhill. This is not water erosion. This is electrical machining.
How do you know that? I mean, you're
Because
making that claim, but how do you know that's electrical machining? Why can't that just be some geological scarring that we have not yet identified yet as to, the mechanism?
I
I mean,
grant to you that
I don't see how
could,
that's quite a stretch to say that it's electrical machining.
In order to say it's electrical machining, you obviously would have to demonstrate that how much current would be required to flow to cause that kind of arcing. Or was this an arcing thing that you're suggesting? Was this, when you mean by electrical machining, was this produced by electrical arc from a differential in
yes,
voltage? Okay, so you have a
yes.
current flow from a differential in voltage. Can you ask the people at the EU projects to, one, give us the physics that would require how much amperes would be required to do something like this on a planetary scale, and two, when they have observed this ever happening on the planetary scale? Because just because we observe things that seem to have similarities on the smaller scale, and I grant the supervenience principle, well, it's not really a principle, but supervenience, that certain things that happen on the microscopic scale do translate to macroscopic, right? I think most people would agree there's a fundamental supervenience in the universe of certain things, but even in philosophy there's a supervenience. But in this case, where's the data that supports this? Because you're asserting it, as fiat. You're just asserting it as this is the case, but in order to substantiate that, you still have to have reasons to substantiate that belief. And just because it looks similar, it's not a justification to believe something. You need to have the raw data. And when I've looked into this,
Okay.
the Thunderbolt project,
Well,
I never find any of their actual data.
Hey,
look,
Steve,
the explanation so far from the mainstream is that this is a river channel. The mainstream cosmology, when they look at Mars and they look at Valles Marineris, and this is what the explanation is you'll get from mainstream cosmology. When they look at Mars and the channels and Valles Marineris and all the offshoots and channels and tributaries, this is their explanation, that this is water erosion.
Because we've seen
I think
that
we
happen
can
on
all
other
more or
planets,
less
like our
agree,
own.
can we not, that we really don't know the mechanism? I mean, modern science,
Yeah, I'm not convinced.
current science hasn't really identified the true cause, and neither has Thunderbolt's project. I mean, have you ever arc weld? I
Actually,
both gas and arc
have.
weld,
To
and
be
when you
quite
arc
honest
weld,
not a fan of
when
it.
you
be
arc
quite
weld, you
honest
get a
with you
lot
again.
of debris
to be quite
sputtering
honest with you,
when you draw a
to
big
be
arc.
quite honest, I hope you can hear me out. I know there's a lag between our
All right, guys, George was talking. You can't talk over each other because it's
There's a
the
lag.
audience.
Go ahead. Yeah, we got.
All right.
Go ahead, Aaron. Yes, I've spot welded, arc welded, and acetylene torch welded, and I'm not a fan of welding. I'm not going to ever do it again.
I also have spot welded. I also have arc welded. I also have TIG welded, which is also known as plasma welding. I spent a lot of time. I spent several years as a TIG welder, and this is a fact. And when you're TIG welding, there's an argon gas that is produced through a needle, which is forgive me, it just left my brain. I'll remember it in a second.
Well, I'm used
But
to a
this little
soldering
tine-
rod, or I mean,
No,
what are those rods that you use? What are they called? Arcing rods or arc welding rods?
I was never any good at arc welding, but I was very good at TIG welding. I used to weld very, very fine welds on stainless steel with a TIG welder. And the TIG welder has this little needle that is surrounded by an argon gas. And at the tip of the needle is a little plasma ball, and that is what you use to weld with. If you touch the needle, then you ruin the needle. You have to take it out and go and grind it down sharp again. It doesn't work if it's not fucking sharp.
You know, I can get that, yeah.
But I don't think the
plasma.
universe does any TIG welding on Mars. I mean, if you're going to try to compare this to electrical discharge, the closest you're going to come to is more or less a standard arc welding, where you have a rod, and if you hold your rod above the surface, you end up where you're not ending up with a nice flow of molten metal to fill in the divot. You end up with a very rough looking divot with all kinds of sputtering and debris all over the place, and you'd have, like,
which brings me,
if this was that sort of thing, you'd have big boulders and stuff all over the place from the sputtering that was going on in the arc that's going across the surface there.
That's right. And if you have experience as an arc welder and you understand the sputtering that happens, you know that what you get are these little tiny balls, these little round nodules
Mhm.
that are remarkably similar to what have been dubbed the blueberries on Mars.
But I don't see these the sputtering debris next to this channel here.
Yeah, and here's the thing though, Aaron. Just because there's similarities, there's only look. Maybe I can address it this way because we do got to start wrapping it up. There's only a certain amount of things shape-wise in the universe, right? We have fundamental primitives there. Okay, a primitive would be something very simple like a shape of a circle, square, hexagon, triangle, right? There's only a certain amount of primitives that go around. We're going to see similarities in many different places, right? So just because you see it in one case, that's something, and you go, oh look, it also appears over here. There's some similarities there because, again, there's only so many different things in the universe that we can ascribe these events to. So when we're saying we look at this, we have to have the reasons physics-wise why we see something like this. And science goes out of its way to try to determine what those explanations are. Now, I don't think we have determined exactly what these conditions are that made these things, right? I think there are still up for evaluation. But let's suppose that it is something like water erosion or water flowing. We've seen that on the Earth, right? So we can make a jump on that correlation.
We've never seen water go uphill.
Sure we have. Yeah, water can go uphill. Just as long as you have a differential in height, water can go uphill for a little while and then come back. So yeah, of course you can't. You can't go uphill if you have difference in height such that you start from the bottom and you go to the top. No, of course not, because water is always going to flow from the higher potential to a lower potential. But
Dave,
we've seen these things happen on planetary scales. I think the EU is they're not, for whatever reason, happy with established science, right? They're not happy with the fact that people are promoting actual demonstrable things, and we've accepted certain paradigms to be the case, right? Relativity is not going to be overturned anytime soon. They don't accept theory of relativity. They don't accept general or special relativity.
They don't accept black holes or dark matter either.
Or dark energy, yes, right. And so the things that are in
Dave, go to 2.3, please, while he's talking. Go ahead, Steve.
They got a background noise.
Okay.
Who's watching a video?
Dave, back up one slide, please.
Are you hearing a lot of background?
Yeah.
I'm hearing like a TV. Sounds like a TV.
Yeah, it's like
in
a
the
background video.
Yeah, I don't know where that's coming from. Is that coming from
It's
me?
not me.
Because I've checked all my windows and nothing seems to be active. I don't know where it's coming
Dave,
from.
is that you?
Sounds like
It's not
somebody's
me.
got a
I'm
TV.
muted. I was muted. So
Sounds like
no,
a
it wasn't
TV.
me. It was
Yeah, I don't have a TV on the
Yeah, I don't
back.
have a TV
On.
Okay, so anyways, it seems to be gone now. But to wrap it up, if you have a actual theory, right, and you want to get into the scientific arena, and you say, look, I challenge the scientific consensus, I challenge the paradigm, right? That's great. Science wants to be challenged, but I think you're missing the point. Is that these Thunderbolts projects people are not in mainstream, right? They might have mainstream backgrounds, but the theories are purporting to explain these phenomenons are just not practical. I mean, how many trillions of amps would be required to cause, something along these lines? I couldn't even imagine how huge the arcing would be. I mean, it'd be catastrophic. It'd be enough joules to liquefy the planet, probably. I mean, George probably one day in his videos might work out the math if he hasn't already. But George, could you give a rough estimate? I mean, would it not require so much joules, so much heat that the planet probably wouldn't even survive such an event?
Yeah, well, that is the
sun?
point that I made when I first came on, is in terms of scalability. You can make little divots in a sandbox or whatever, or in a plate of sand with electrical discharge where you have thousands of volts discharging onto this plate. You try to scale this up to the scale that you'd be ripping out a crater in a planet. I mean, it's just astronomical, the amount of electrical energy that would have to be required to do that. And again, what puzzles me is if this is the claim as what's created these sorts of features on Mars and the moon and stuff, why don't we see this currently occurring? Why
Well,
aren't we
because
observing this currently?
And also,
according
keep in
to
mind with
the
that,
history, according to the thesis of the Thunderbolts project, the Electric Universe project, that what happened, particularly on Mars, what happened was there was a disturbance in whatever planetary arrangement was currently underway. There was a disturbance, and there were various planetary bodies that came in close proximity to each other. This is where the electrical discharges took place.
Yeah, you're
And so
claiming that
when
like
you ask,
Mars
why don't we see
Venus.
that? Well, that's because we don't see Mars and Venus coming within a couple of
Yeah,
thousand miles of each other.
What? Yeah, George, what he's claiming is that at one time the Earth was a satellite of Saturn, right? And Venus was ejected from Saturn as a comet. Somehow Venus ended up in orbit, and on its way there or something, it interacted with Mars, causing this huge arcing between Venus and Mars. But again, the amount of current that you're talking about there and the amount of heat, I could not imagine these planets would survive such an event.
Yeah.
It wouldn't just
Yeah,
be
well, the
scarring.
amount of free charge that would have to exist on each of these would just be
incredible.
astronomical in order. What you're looking at is what is an electrical discharge. It is charges of opposite polarity trying to seek out neutrality, trying to neutralize one another.
Sure.
And the amount of charge, free charge that would be existing on these things is just, it's unfathomable what would be required to create a continuous electrical discharge. I mean, usually on something like that, where you have masses amount of free charge of opposite polarities separated by one another and you bring it in close proximity, the discharge is violent. It's not a continuous discharge. It's going to be going over a period of time. I mean, we're talking a really violent discharge, like a lightning strike. This thing's going to happen and be over within seconds. I mean, it just seems rather unfathomable to me that.
Well, maybe,
All right. There are two things.
In touch with. Go ahead. All right.
There are two things. Yeah, it's not Aaron, it's Aaron. That's okay,
Yeah,
Steve.
sorry. Yeah, habit, right?
I know, habit. There are two things I want to cover before we close out tonight.
Okay.
The first thing is the phase lock of the moon and other moons, because our moon is phase locked to the Earth. That
well, you mean tidally locked, not phase locked.
You mean tidal locked? It changes phases, but it's tidal locked because it's in it's in synchronized rotation with the Earth. So it's yes, tidal lock, but I also mean phase lock electromagnetically. It's not our moon is not unique.
Explain phase lock. I mean, that's just a word. You're using a word. I mean, I see people doing this all the time.
Okay.
The mind of God. He loves to use orthogonality when it comes to talking about gravity. But what's that mean? Define it.
I know what a PLL circuit is. A PLL circuit would be a phase loop lock, right? But I don't think what he's referring to.
It's electromagnetically locked in place so that one side is facing Earth at all times. And our moon is not unique. There are many other moons in our own solar system that are quote unquote tidal locked or phase locked to their parent star or parent planet.
Well, I suggest you go to my channel. I also have a video describing and talking about tidal locking of the moon to the Earth. It hasn't always been tidally locked.
Give me the name of your channel. Give me the name of your channel.
I'll give you the I'll post the video in the side chat.
No, I really.
The only use of the phase lock I've ever seen is that George obviously knows this because he's an electrical engineer and he's brilliant on this stuff. But there's something called a PLL circuit. It used to be like in radios, you have a PLL, which is a phase loop lock, which is used for tuning. That's the only time I've ever heard that terminology ever used.
Yeah, phase used in the way he's doing electromagnetically. What it means is that you have two it has to do with sinusoids. If you have two sinusoids that are fairly well matched in time, just differing a little bit in time, we talk about phase. If the timing isn't real close, then we have time delays and we have a different frequency. But when two
Sure.
sine waves are close in frequency but not quite in time synchronous, we can describe them as being having a phase difference. And
It's
I get
it's almost
I
like
get
if you've ever
disturbed when
if you've
people
ever
start using these terms indiscriminately.
all
Well,
right,
yeah,
I
like
apologize.
cosine and sine waves are going to be 90 degrees out of phase, right? So that's what he was referring to.
Yeah. So
Okay. How does that work for the
it's
moon,
almost
though?
like if you've ever seen those videos where somebody takes a superconductor, a ultra cooled superconductor, right? They cool it down to minus whatever the fuck, and they drop it onto a circular magnet, and they can crank it in any direction, and it stays in whatever position they put it in, and yet it'll circle around this
Yeah, superfluid. Yeah.
Yeah,
So
that is not a phase locking. All that is eddy currents creating an opposite magnetic field. It has to do with what we call Lenz's law, is that if you put a magnet above a superconductor, it induces a eddy current in the superconductor that creates a magnetic field of opposite polarity to the magnet that's being levitated, and you have a repulsive magnetic field that holds that magnet above the superconductor. It's just two opposing magnetic fields.
it'd also be a
Okay,
Faraday's
fine.
law, would it not? I mean, you eddy currents like hysteresis losses. I'm trying to remember.
Well, you have no
you have
hysteresis losses in the
No,
semiconductor, and you have
no,
an eddy current that just
but there's
flows
they're still
below
similar. They're
below the magnet, and it'll circulate forever because there's no losses in the
right.
in the
No, that's not what I meant.
superconductor.
No,
no.
what I meant
George
is
was
simply
more.
the eddy currents would be these isolated loops of current due to a changing magnetic field, and that would be Faraday's law of induction, correct?
Right.
Okay.
Okay,
Yeah,
so
hysteresis losses
all
would
right,
be very similar things for heat
all right.
dissipation,
So
like in the iron core.
all right, so George was more correct, and I apologize for using the wrong terminology. George was more correct when it comes to the superconductors and how they are held in place, but nevertheless, it's still electromagnetic force that still holds them in place. The other thing I wanted to bring up before we close out is counter-rotating, not only counter-rotating electrical fields, but we have counter-rotating weather patterns on Earth, Saturn, and Jupiter have been observed.
But that's Coriolis forces.
No, I'm talking about counter-rotating weather patterns.
Yeah, it's due to Coriolis forces.
That cannot be a Coriolis.
What can it?
Maybe I'm fucking stupid. I don't see how you could have a weather pattern. Somewhere I've got an image. It's not a video, but if you want, there's a video, and I think Thunderbolts has a copy of. What you want to do is just look at the south pole of Earth, the weather patterns, or the north pole of Saturn, or even look at Jupiter from, say, an equatorial viewpoint. That there are, like Jupiter, for instance, there are as many as 15 different counter-rotating weather patterns. So the winds are whipping around in completely opposite directions, one over the other, over the other, over the other, over the other, 15 layers thick.
Yeah, well, weather patterns are very complex. I mean, they're due to temperature gradients, Coriolis forces. There's many different forces that come into play in determining weather patterns.
And just a point of correction,
These are
what that image you had of the Mars thing that we thought was erosion, right? That's actually a picture of the moon, not Mars.
Oh, okay. Sorry, my bad. Usually I try to capture the source in my screenshots. And like I said from the very, very start, that almost all of these images are taken straight from Thunderbolt's website, Thunderbolt's YouTube presentations.
Yeah.
Do you think it's possible they just be maybe willfully misleading people, Aaron? I mean,
No. This particular
you don't think so?
instance, I'll accept fault on this one. I thought it was Mars.
No,
Apparently
not
this was
that.
the
I'm talking
moon.
about
My bad.
Yeah, this is the moon. But I'm talking about as again, this is why we don't make, we try to avoid certain claims, like when we see canals on Mars and things on Mars, we don't know what causes them necessarily, because there's still some deliberation on what's out there. This is why even George and I said, well, it could be this, right? But
Okay,
could it be that
so back to could it be that they're willfully misleading?
Could the EU people either be willfully misleading people for their own agenda, or just be, whatever reason, grossly misled? Because you have PhD, and I'm not trying to compare you to other things, but you have PhDs in creationism, and even you're an atheist. Your creationism is bullshit, right?
Sure.
So just because they have a PhD in front of their name doesn't really mean that when they promote these pseudosciences that they have anything credible. So don't just think that they have a PhD, they're putting forth correct information.
I just posted the link for my title locking of the moon video. It's at 10:30 p.m. Central Time in the side chat there, in the live chat.
Okay. All right. I just want your channel, so because I will go and check out what you have on your channel.
Just go to that video, and then you can pull up my channel from there.
Yeah, going in, you need to know a little bit of math watching his videos, but they're well worth watching.
The channel is actually listed in. The channel is actually listed in the inside chat, as well as the description of the video for this show.
Yeah.
So
but we're gonna have to wrap this up, Aaron. So.
Okay, so
I mean, the physics is very well known as to why we only see one side of the moon here on Earth. It just has to do with an exchange of angular momentum between the Earth and the moon, and eventually the Earth will be also tidally locked to the moon, but that won't occur for several 100 million years. But the Earth is slowing down to the point where eventually the Earth will stop rotating, and both the Earth and the moon will be tidally locked to one another.
Yeah, and you can find videos on this, watching the ocean lag, and you can watch the conservation of angular momentum and why the moon is no longer have rotation, also causing it to recess from the Earth too. Some of the same forces cause the Earth and the moon to recess from each other at a few centimeters.
It's about 2 centimeters a year, annually. I think, something like that.
Yeah. So I mean, that's because of very similar forces.
Look, I understand the tidal lock of the Earth and the moon, and I've contemplated the moon for many, many years as to why we only see one side, and what a weird coincidence that its rotation matches its orbit so that we only see one side. What a wild coincidence. And I've contemplated that for many years, and what would cause that, and maybe it was a weird coincidence, but it seems to me that electrical or magnetic forces or electromagnetic forces would actually explain that quite perfectly.
It is not a coincidence, though. A coincidence implies there's no causal mechanism, right? But there is a causal mechanism by which we know the moon.
That's what I'm saying. That's what I'm saying, is that the causal mechanism seems to me that electromagnetism might actually be a better explanation for causal mechanism.
Not even remotely close. I don't see how any we have the phenomenon of the sun, the Earth and the moon being in the same rotation is well known. I mean, this is something that's not even questioned. So I don't know why you would say that you think they have a better explanation when we have an explanation that actually works and can be demonstrably demonstrated via mathematics and physics.
Okay, I know you have an explanation, but our moon is not the only moon in our solar system that does that.
Okay.
So
again,
I mean, so now we're back to coincidence. Wow, we've got a moon that's tidally locked, and so do other planets.
I don't know how to use the word coincidence, but unfortunately, we are running real with time, and I know Dave is tired. He's had a very long day. George, I want to thank you for coming in as always. You are one of the most brilliant people I know. You guys don't even know the depths of this guy's freaking knowledge. almost obscene how smart this guy is. I mean, I put him on the same category as Landon Kurt Knoll. Both of them are just beyond exceptionally brilliant. So take what they say and run with it.
Maybe when you get Wal Thornhill on here, you can get George back on.
We would love to.
And Wal.
Yeah, no, I think George would like that. George, would you like that?
Yeah, anytime. Just give me a heads up so I don't have such a trouble with getting on with the computer.
Yeah, we'll work with you on that so we can do it through vMix.
Yeah, just do it through email is the best way.
Okay. Yeah,
well,
I'll reach out to them.
I will readily admit that I don't have the scientific background to go head to head with George. So I would urge you to reach out to Wal Thornhill, who is not that hard to get a hold of, I understand. But see what you can do. I would love to see you get Wal Thornhill on here. And
I'll check it out, dude.
And all I can do is do my best to try to represent the EU from what I have learned from their own website, their own symposiums. But I will ask you this before I shut up and let you close out. You asked a moment ago about why or if first you asked if and then why about maybe are they willfully misleading people. Why would so many PhDs, why would so many millions of dollars on the Sapphire project, who is closely associated with the EU, why would they spend the money? Why would so many PhDs be involved? Are they willfully misleading people? So my question to you is, what would their motivation be? What would they have to gain?
Some scientists, but not others.
Mm-hmm. Yeah, that was my question.
So my question to you is, what would they have to gain?
You're asking me that question? Because I was asking you that question. I have no idea what they have to gain.
No, my question to you is, what would they have to gain from that? If it's true that they are willfully misleading people, what would they have to gain from it?
Yeah, I have no idea. I mean, they're not making enough money on books and donations to cover the cost of how much they'd invested in the Sapphire project. That again, I believe has produced absolutely nothing. It's like a full errands thing where they're just tilting at windmills trying to reinvent the wheel for whatever their reasons. I don't know their reasons. They might have reasons that's not known to us. It may not be just because of science. I mean, look at the young creationists. Their agenda is because, they want the earth to be 7,000 years old because of Bible teaching, right? Has nothing to do with the science. They don't care what the science says. They'll warp the science any way they can to fit their narrative, right? They have a presupposition that the earth is 7,000 years old, regardless of what the science says. And it just seems to me that the Thunderbolts project, for whatever reason, I don't know, we can ask Thornhill if we get him, but they seem to have a presupposition that the electric universe theory is the dominant case of the universe, that electricity is the dominant force of the universe. But that seems to be a presupposition, because it's surely not a conclusion, because I know George wouldn't conclude that. I wouldn't conclude that. No reputable physicist I know would conclude that. So I think they started as a presupposition and try to find evidence that supports the presupposition rather than just confirm it. That's just as somebody, as an outsider who looked into it. It seems to be the case. But again, I don't know their motives. We will have to ask them. But I'll try to get them on. Does that work, Aaron? And by the way, I know you're not.
Yeah.
By the way, bringing something like George is like a heavy hitter, right? I get that, right? I mean, very few people compete on his level. But we're not really asking you for the physics, and I'm not trying to. I'm more interested in just why you believe something just so cavalierly, because we already have these dominant theories that work, and yet you're so willing to just toss them aside and say, you know what, I'm more willing to believe this alternative pseudoscience that everybody in reputable mainstream calls pseudoscience without really understanding the physics behind it, right? And I don't understand your reasoning why you don't want to.
All right, well, here's my answer. Here's my reasoning. Number one, here's my number one reason to answer your question is because of a presentation that I saw from Thunderbolts Project on the Valles Marineris, which is the scar on Mars, which is a third of the way around the planet, which is consumed and removed something like 1 million to 3 million cubic miles of material, and there's no water inlet, there's no delta outlet, and that the tributaries end in what are known as crater chains. There are no tributaries there, so there's no there's no explanation for water erosion.
Why would it have to be water erosion? Why couldn't it have been maybe early in Mars's life when there was some shifting of the crust on Mars, like we experience on the Earth? Why couldn't have maybe the crust separated a little
Because
bit there and created
because
that belt?
Geological formation.
because all of what are known as tributaries are turned out to be crater chains, which are
Well, I tell you what,
again
Eric,
are repeatable and demonstrated in laboratory experiments with electrical discharge. They create these crater chains, and
Yeah,
again,
but on a
electricity is
very
scalable.
small scale. You're talking something here at so many orders of magnitude larger than anything you would be doing in a little sandbox or in a
Sure,
petri dish
sure, I
or on
get
a
that.
plate in a laboratory. I mean, you're talking removing, grams in a laboratory versus what here? Metric orders of magnitude of metric tons of material. I mean, big difference here.
All right, my number 2 example, and I will promise I will shut up after this, and you can close out. My number 2 reason is that dozens upon dozens and dozens of examples that the EU provides of NASA scientists and cosmologists and planetary physicists who are constantly scratching their heads and making public statements saying things like, well, we didn't expect this, and we thought this was going to happen, and we didn't understand why, and we have to go back and figure out this. I have in my presentation here, we didn't get a chance to cover them, but I have at least a dozen or nearly a dozen quotes, and there are many more than I have provided here tonight that we didn't even get to, of all these publicated examples of NASA and cosmology saying things like, well, we thought this was going to happen, it didn't happen. What we expected, it was unexpected, and we're scratching our heads and we don't fucking understand.
But that's what
Right there.
science is all about. We
that's what it
love
does.
to
That's what it's supposed to do.
find things that
That's
don't
right.
fit so that we can, if we have to, we go and modify our existing theories. We don't throw it out with the
No,
bathwater. What we try to
I
do is take our
totally
existing theories and modify them to an extent to incorporate new observations and new data.
I
Yep.
totally
I
understand.
gotta
That's
wrap
what
this,
science
Eric.
is all
Science.
made of. This is the thing that makes science interesting, is if we find something new that doesn't quite fit, now it's upon us to go out and find an explanation for it.
Yep,
Except
I mean,
that the
just give it
electrical
time, we'll have.
real quick, I do got to wrap this up. We're going way over time. Let me just tell you, I do have a friend who's a planetary scientist. He's been on before. He's a very good friend, Dr. John Kroon. Really amazing guy. The current model, and I've seen if he can come on next time maybe and join in and talk about the geological scar on Mars. Marineris, is that how you pronounce it? Marineris, right?
Marineris.
Marineris. From what I understand, it was caused by groundwater that eventually caused what's called sapping, where you have these underground water here, and then you have like geological formations kind of break down into it, right? So it undermines the rock, and so it kind of collapses in itself, and that's the leading theory from what I understand, causing that
theory. That material has to go somewhere, Steve. Right. That material has to go
well,
somewhere.
No, it's underground. It's underground. It's underground. I mean, it just collapses under itself. But I'll tell you what, I reach out to John. Maybe he can come in and talk about that specific thing next time if you want to come and join us. Because I am more interested about your beliefs rather than you presenting the science. Because as you said, you're not a physicist, you're not a scientific expert on anything. And I get that. I'm not trying to put you on the spot. But we will get somebody for the science. Like if we get Thornhill or somebody to come in, and we'll have somebody like George's caliber, or maybe Dr. John Kroon to come in with George. And kind of go head to head on the science itself, because the science itself is going to require a lot more in-depth discussions that I'm incapable of doing at the moment, because I haven't looked into this stuff in ages. I haven't taken electrical theory in ages. I took, my basic courses in electrical theory, but that's nothing compared to the level you need to have a conversation of this caliber, I think. So
sure, exactly.
Anyway, I want to thank you both for coming on. I want to wrap this up. Thank you all for watching.
Steve.
Sorry we had this so late. George, always a pleasure to have you on. Yes,
Nice
George.
to meet you, George.
Contact me via that email that I gave you. That email that I have, steveaskanything@gmail.com, is a public email. Anybody can message me on that. Let me know what you think in the video. Again, I'm already going to capitulate that probably glass not flowing is more mythological. However, there seems to be and George, you might do a video on this as well. I'm curious about that because it's not just the medieval glass, but the glass as a whole, as an amorphous solid, which I believe it is, doesn't have liquid characteristics. Because I am convinced for a fact, though, that plasma is a fluid. I don't know. I mean, George, did you know anybody would think that plasma is not a fluid?
I wouldn't call it a fluid necessarily. I mean, fluid dynamics, the fluid equations apply to plasmas.
That's kind of what I was saying earlier. Is that when you have like that plasma does display characteristics of a fluid, like if you had a dense
because
plasma,
it is the
for
fluid. It
instance.
flows. Anything that flows is the fluid.
Well, if you had a very
I
dense
guarantee
plasma
plasma is a fluid.
that you could create literal chondritic waves. So plasma does have characteristics of a fluid, and yes, it flows and it has a lot of characteristics of fluid. So I wouldn't say that it is a fluid. Plasma has characteristics that fluid does not have. That's all I'm trying to say.
But that doesn't make it not a fluid, right? Well, I'll tell you what.
Right.
We'll leave it with that.
Fair enough.
Guys who are watching,
I'm not dying
if you're
on
physics
that
people,
hill.
let us know what you think. Is plasma a fluid? That's going to be the next thing, like is data virtue, which, by the way, it's not. People don't believe Kyle. He's wrong. But let us know what you think about that, because I'm convinced that plasma is a fluid. It definitely has the same attributes as a fluid. It's not a liquid. It's not a gas. Clearly, it is an ionized state of a gas, but it has the properties of a fluid, so it falls into fluid dynamics. I do remember that. So anyways, guys, we're going to wrap this up. And thank you for watching. Dave, take us out so we can go home. Oh, wait.
Non sequitur. Your facts are uncoordinated.